Hello YouTube and Mother. I wanted to give an update regarding the some of the testing I've been doing on the power pack with the reliable inverter. So I've been running these two electric oil heaters for like the last probably 2 hours, maybe hour and a half. And the reliable inverter has been holding up pretty well, actually. Just for when I started the test, I ran both heaters on high for like 5 minutes, and it operated both of them, and both of them are running. I only have one plugged in right now, this one right here. It's set on high, and I have that connected to a kilowatt or a watt meter, and you can see it's drawing 1360. This one isn't plugged in yet, or I have it unplugged because I just wanted to show a test here, take video of it actually running maybe 2800 watts continuous without a problem. And you know, I know it's a love-hate relationship with these inverters, but I think it can do it, and if it can do that, it will be able to meet my needs. So I'm going to unplug the one that's running right now and plug that directly into the inverter. Alright. So you can see the voltage on my battery is drained pretty low. I do want to drain this down until the BMS tells it to stop. I want to test the shutoff voltage of the BMS. I can set that, but I want to make sure that's working. The output voltage sagged a little bit. It was at like 124, 125 before I plugged it in, but you can see this heater's back on high. And then I'm going to plug this one in. So the fan just shut off on the inverter, but the heater's still running. You can see the two lights on down there, and I can check the app for the BMS and it'll show that it's still pulling current. So right now the heater I'm plugging in is set on medium, so it's not going to draw the full 1400 watts, but you can see it's pulling 900. So the fan just turned back on the reliable inverter. It seems to be on a thermal switch, so it's not time or load. It's definitely a thermal switch. So I guess 900 watts here, and you saw 1350 here. That would be what, 2250 right now out of a 3000 watt inverter. Now the quality inverters, you guys know, I used to have a Thor. Oh, I forget who actually made the Thor, but it was a high quality one. You know, their watt rating would be 3000 watts. That means it could probably surge to like 6000 watts for a few seconds, and the good quality ones could surge to like double their rating for 10 seconds or even longer. I don't know what this one can do. I haven't really seen anyone capacity test them like that to see if it can surge to, like in this case, it should surge to 6000 watts. I doubt it can do that, but I'm kind of happy right now that right now it's running 2250, and I'm going to turn the second heater on high and cross my fingers. Of course, right? So I said I did this test earlier. That was right when I started it. I ran both heaters on high, which were each 1400 watts about, and it ran it for a few minutes. I ran it for 5 minutes, and I didn't want to babysit it the whole time, so I turned the second heater down to medium, which you saw it drawing 900 watts, and then meaning the inverter was running around 2200, 2300 watts, and it was running fine. It ran like that for an hour or two. So see, we just came up back on by itself. I'm going to turn down the load. I wonder if that was actually a voltage shutdown from the BMS, just because of the draw got that high. But you know, the display says 48.8 volts. I think I have it set to shut off at 42 volts. So I don't know what to do. The case isn't hot at all. You know, the air coming out is warm, but it's not hot. BMS is warm, but not hot. I can take a screenshot of the temperature there. I'll have to check to see if it was the BMS that shut down or if it was the inverter. My cables, my red single cable that I have here, which I plan on upgrading, is slightly warm, but not. I expected it to be hot. It's not. The only part that's really hot within the whole bank is, for whatever reason, this bridge that I created to connect these cells. This is hot. I can't keep my fingers on that for more than like 4 or 5 seconds, and it's hot. These ones back here, these are not hot. These aren't even warm. So I don't know why. This is hot. Yep, hot. All right. I'm going to stop the video. I'm going to check the app and see if it told me that it shut itself down or if the inverter shut itself down. And then I'm going to try running the test again. So right now you can see I'm pulling about 900 watts from this heater down here, which is on medium, and this one is still on high. So this one's pulling 1300 or 1350. And I'm going to try the test again to see what actually shut it down. Okay, I checked the app, and it was actually, or the BMS app, it was actually the BMS that stopped the current flowing to the inverter. I had a over discharge current warning on the BMS, so it must have just got, that must be a setting that says to do that. I didn't look through the whole parameter list again, but I think this is a 60 amp BMS, and I bought it thinking, okay, 60 volts, 58 volt, fully charged, 52 volt nominal battery pack. I need 3,000 watts, so I need a 60 amp BMS. I probably should have went with the 100 watt or 100 amp BMS just to give myself a little bit more wiggle room, but I guess we'll see. I'm going to turn the second heater up to high again to see if we can run at 2800 watts again. So here we go. No. So, and if we look at the inverter, it has zero, it's reading 0 voltage, which I think, knowing what I know now, I'm not concerned, but before I was like, oh crap, did I just blow up this inverter? But it's actually the BMS that's shutting down, which is good because that's what it's designed to do. And I would imagine it's just going to turn on by itself again at some point. I'm going to turn that down to low. Okay, so it's turned itself back on. Again, you look at the limited information we're getting from the inverter, and it looks fine. The BMS said, no, not going to do that. So that's good, right? I mean, it's good to know that the bottleneck in my system right now is the cheapest component in the system. So I don't remember what I paid for this. It was between $40 and $60 for the BMS. The inverter was $324 or something like that. So yeah. Now I'm kind of interested to know what the maximum current I can draw on this before my BMS shuts down. Or I need to order a new BMS, which will then probably move my weak point or my bottleneck to the inverter, which is, I have to decide if that's something really I want. All right, that's all I got for now. Thank you. Okay, real quick, I did confirm that the over discharge current is a value that I can change within the app. It was set at 70 amps, and then there was a cycle time of 32 seconds, so it means when it gets engaged that the BMS won't turn back on for 32 seconds. So that's why we saw it turn off and then turn itself back on automatically. That was all being done in the BMS. This is one of those interesting questions now. Do I increase that current setting within the app and keep testing? Or do I protect myself from myself? I think it would be great to be able to pull a full 3,000 watts continuous out of this inverter, but I don't know if that's expecting too much out of it. And I don't know if that's an actual need I will have for the purpose why I built this inverter, which was to power a travel trailer when there's no shore power. There's no power provided by the campsite. So, I mean, there's certainly a minimum level of watts that I could get away with if I was being real conservative. I would never really need over 1,000 watts if I wasn't going to run, the toaster or the microwave or any of those high drain devices, but appliances. But it certainly would be nice to be able to if I want to. I don't know, we'll see. I think I'll leave it where it is for now, and then maybe start playing with that setting once I have it actually hooked up to the travel trailer and I can test to make sure that it can do what I need it to do. Thank you.